All right, in these notes, we're going to take a look at parallel and perpendicular lines, specifically how to write the equations and how the equations of these lines compare to each other. And so let's take a look at this first picture here. And we're going to write an equation for each line shown in the graph. Okay, so for line A, first we know it has an intercept of -3. And if we count for the slope, it looks like the slope is -2/1. So that would be y equals -2x minus 3. All right, for line B, it has an intercept of 4, and it looks to be a slope of +1/2 from point to point. That would be y equals 1/2 x plus 4. And for line C, starts at -1, and it looks to also have a slope of 1/2. So y equals 1/2x minus 1. Right, just pick 2 points and then count up and over or down and over. Just remember, positive slopes go up to the right, negative slopes go down to the right. Okay, so if we look at these lines, we can see that B and C are parallel. Parallel meaning they kind of run the same direction and will never intersect each other. And if you look at those equations for line B and line C, you can see they have the same slope. So lines with the same slope end up being parallel because their slopes don't allow them to intersect. They're the same. So parallel lines have the same slope. Or equal slopes, or identical slopes, same number. Now perpendicular. If you look at line A there, it cuts across B and C perpendicularly. And remember, perpendicular means it has a 90-degree angle. So it can't just intersect, it has to intersect at 90 degrees to be perpendicular. And so if you compare the slopes of line A and line B and C, you notice two things. One, first it goes from -2 to 1/2. Okay, so there's two things that are happening. One, the fraction is flipping. We have 2/1 flipping to 1/2, and it goes from negative to positive. And so for a line to be perpendicular, for two lines to be perpendicular, they have to have two of these things be true. Both things have to happen. First of all, their slopes have to be opposites, because that's positive and negative. Then they have to be reciprocals. So they have opposite reciprocal slopes. It can't just be opposite, it can't just be reciprocal, it has to be both for those two lines to be perpendicular. So let's compare some lines down here and see if they are parallel, perpendicular, or neither. So we're going to be comparing the slopes. For example A, they both have a slope of 5. So these would be parallel because those are the same. For B, one has a slope of 7, one has a slope of 2. So these are neither parallel nor perpendicular because they're not the same, and they're not opposite reciprocals. For example C, we have 3/2 and -2/3. So our slopes are flipped and opposite. So this is perpendicular. And finally, for example D, we have 5 and 1/5. Well, they are reciprocals, but they're both positive. So this is, again, neither, because they're not the same, but they're not both opposite and reciprocal. So those have to be neither. The other thing we can do with parallel and perpendicular lines is use what we know about the slopes to find the equation of a line that is either parallel or perpendicular to a line we already know. So example 2 says, given y equals 3x minus 1, write an equation of a line with a y-intercept of 7, that is A parallel and B perpendicular. So for parallel, we know that the slope is going to be the same, right? The slope here is 3, so our slope is going to be 3. And for perpendicular, we know that the slope is going to be the opposite reciprocal, so -1/3. right? And if we know the y-intercept is 7 for both of these, the parallel line would be y equals 3x plus 7. And the perpendicular line would be y equals negative 1/3 x plus 7. Right? Because all we have to do is change the slope according to the rules that we can see in the graph above. Now that was when we were given the y-intercept, it was a little easier. For the next example, example 3, we are given the equation of a line, y equals 4x plus 1, and a point that line goes through. So we have to use something called point slope form, which you may remember. Looks like this: y minus y1 equals m times x minus x1. And so what we're going to do is fill in what we know about these lines into this structure and then solve for y. Okay, so first let's consider the slopes. Our parallel line will have a slope of 4, and our perpendicular line will have a slope of negative 1/4. Right, and for both of these, we're going to use the point 4, negative 3, because that's the point we're given in the problem. So now let's fill in what we know. We know it's y minus y1 equals m times x minus x1. And what those y1 and x1s are the x and y values from the point we're given. So to set this up here, it'd be y minus negative 3 turns into plus 3 equals the slope is 4 times x minus 4. Okay, so again, that was y minus y1 m times x minus x1. And so that 4 ended up here. That's x1. That's our x value. The negative 3 ended up here and became positive 3 because we had minus negative. And our slope is 4, ended up there. The other parts of this equation format don't change. So now we just solve for y. Distribute the 4. So y plus 3 equals 4x minus 16. And then minus 3. Y equals 4x minus 19. So there's our parallel answer. And now let's fill out the next one, perpendicular. Again, it's y plus 3, because of that negative 3, equals negative 1/4 this time, x minus 4. So it's practically the same setup, just a different slope. So now we distribute the negative 1/4. So y plus 3 equals negative 1/4 x plus 1. 1/4 times 4 is 1. Remember to multiply a fraction by a whole number. Multiply by the top, divide by the bottom. Oops. Multiply by the top, divide by the bottom. Okay, and now we just subtract 3. So y equals negative 1/4 x minus 2. Okay, so knowing the rules for parallel and perpendicular, parallel having the same slope, perpendicular having opposite reciprocal slopes, allows us to find the equations of lines that we would otherwise not know enough information for. But we can use a parallel or perpendicular line to gather the slope so we can actually write the equation.